Okay. In this last one, number 10, we have quite an ugly expression here. Most of you probably will be a little intimidated at first at looking at this expression. But there's no need to worry because we're going to have some friends in this problem that will allow us to factor this quite easily. Um, so just remember the steps. First, we're going to need the factor numerator, factor denominator in the first fraction, switch the division to multiplication, and then factor the numerator and denominator here, but then flip this fraction as we go to write our problem for our first step. So let's start with our first fraction here. Looks like we do have a common factor here. And if we take a common factor out of this trinomial, it's going to make our life a lot easier in the next step. So let's go ahead and do that. For 6, 32, and 10, it doesn't appear that 6 goes into 32 and 10, but it appears 2 does. So let's go ahead and take a 2 out of that. If we take a 2 out of that trinomial, we're going to have something minus something plus something. So let's see what these terms are going to be. Take a 2 out of 6x squared, and that's going to leave you with a 3x squared. Then if you take a 2 out of a 32, 2 times 16 is 32, so that's 16x. And you take a 2 out of the 10, and that leaves you with a 5. Okay? So this here is a little simpler quadratic than the original, and you might be able to factor this trinomial still. So let's go ahead and see if this trinomial here factors into two binomials using opposite of FOIL. Okay, so if we do that, looks like the first term in each has to get you 3x squared, so you don't have any options there because the only factors of 3 are 3 and 1, so that's going to be 3x and an x. For the last terms have to multiply together and get you a 5. Don't have any options there other than a 1 and 5. And recall this middle term here. This is a 16. That's a pretty big number based on the fact we're using a 3 and a 5 for our first and last terms. Well, if you look, if we multiplied the 3 by the 5, we get 15, which is awful close to 16. So let's go ahead and try to put the 5 in the location that would ultimately get multiplied by the 3 for the outers and inners. If we put a 5 here, then this is going to have to be a 1 here because 1 times 5 is 5. Okay? And since our last term is positive, we know our signs have to be the same. But since the middle term is negative, we're going to have to use both negatives here. So let's see if we end up with a negative 16x. 3x times negative 5 gets you negative 15, and negative 1 times x gets you negative 1, negative 15, and negative 1 gets you negative 16. So apparently this is factored correctly. So I'm going to go ahead and put a line through this, and I'm going to bring this 2 up because that's 2 is still one of the factors of that trinomial. So let's move to the denominator. In our denominator, looks like we should check for a greatest common factor first since there's just 2 terms. And for 3 and 15, looks like there's a common factor of 3, and there does appear to be an x in both, so we can take out an x as well, which is going to leave you with something minus something. So take a 3x out of 3x squared, and you're just going to be left with an x, because remember 3x times x gets you 3x squared. And you take a 3x out of a 15x, well, that's just going to leave you with a 5. Okay. Now, the next step is to take that division and change it into a multiplication problem. And now we're going to have to rewrite our second fraction into factors. So remember that our numerator will become our new denominator, and our denominator will become our new numerator. So let's look at our new numerator first, which comes from this denominator. Is there a common factor? For 2 and 32, since they're both even, there has to be a factor of 2. So let's see what we're left with. We're going to be something minus something. So take a 2 out of 2x squared, you're left with an x squared. Take a 2 out of 32, and that goes in there 16 times. So what we should do, since this is an x squared, we should check to see if that factors. We have 2 terms. We've already taken out the greatest common factor, so our only real option there would be a difference of squares. So let's see if that's a difference of squares. looks like x is multiplied by itself to get x squared, and a number times itself to get 16. Well, that would be 4. And since this is minus, this will factor into conjugates. Okay, and we should be familiar with conjugates. We've used them quite a bit, which means the first term in each has to be the same, and it has to get you x squared, so those are both x's. The last term in each has to be the same, and they have to get you 16, so those are both going to be 4's. And then, because we know conjugates are opposites, one of these is going to be plus and one's going to be minus. And then again, this factor of 2 remains there. We're going to move it up on top. So that's our numerator. For our denominator, looks like we're going to have some options here. So it does not have a greatest common factor, so we're going to have to do opposite of FOIL. Okay. And since this is going on the bottom, notice that the first term is a 3x squared. Well, that doesn't give you any real options there. We're going to have a 3x and an x. But notice that at the end, one of these terms here is most likely going to cancel with one of the terms from the top. Well, if we have a 3x on the bottom, notice that we have a 3x minus 1 on the top. Well, there's a high probability that this term might cancel with that one. So let's see if this friend over here can help us out. So let's try writing that as a 3x minus 1 and see what the rest of this would need to be. And let's make sure we get our middle term at the end. Well, if this is a negative 1, then this term here would need to be a positive 4, because a negative 1 times a positive 4 would get you a negative 4. Now, I'm not convinced that that's the right term. What we need to do is make sure we get a positive 11 with our outers and our inners. Well, if we multiply 3x times 4, you get 12x. If you multiply negative 1 times positive x, you get negative 1x. When you add these together, what do you get? Oh, you get 11x. So apparently that is the right set of factors. So now we've got all of our terms factored. We're ready to cancel. And this is my favorite part of the process, because all you're doing is looking for pairs. So do we have a pairs of 2? Do we have a 2 anywhere in the denominator? Recall, you can't cancel 2 2's in the numerator. That's not allowed. It has to be 1 from the numerator with 1 from the denominator. And apparently we have none of those. So now we want to cancel this 3x minus 1 with a 3x minus 1 in the denominator, and apparently we do have a 3x minus 1. Recall, you can't cancel this 3x with this 3x because this one's attached to the negative 1. On the next term here, we have an x minus 5. It looks like there's an x minus 5 in the denominator, so those can cancel. We've already determined that there's no factors of 2 in the denominator, so we can't cancel that. Do we have an x plus 4 in the denominator? Yes, we do. So we can go ahead and cancel one of those. Is there any other is there a factor of x minus 4 in the denominator? And apparently there is not. So we're ready to write our final fraction on this problem. So at the top, looks like we have a whole number 2 here and another whole number 2 here. Multiply together will get you a 4. And then it looks like the only other term we have at the top is an x minus 4. So this is 4 times x minus 4. And in the denominator, looks like the only value we have down there is a 3x. So here is your final simplified fraction in number 10.